So here's what I'm going to do is a video, and we're going to talk about partial fractions. Well, partial fractions is going to be useful to us when we start to talk about Laplace later on in the course. But nice and early on, it's really good to see if we can solve some partial fractions and get ourselves into a position where we can do some work on them. So let's take a nice simple one. This one is y equals 1 over x minus 2 x minus 3. That looks fairly simple, and it is really. Now in the partial fraction terms, then this can be simplified such that we have, I'm going to try to make it a little bit neater, x minus 2 x minus 3 equals, and this is where we do the partial fractions. We have a over the first term, so we split this fraction, so it's x minus 2 plus b over the second term, which is x minus 3. So a and b here are our unknowns. There's a, there's b, and what we need to do now is to solve that for what our unknowns are, need to be determined. And there are a couple of methods which we're going to use in order to do that. There's a sort of longhand method, and then there's a shorthand method. So if we were to change the colour of that, if we were to take this first term here and multiply that out so that we can turn this into a nice flat equation, then we will get 1 equals, and what I'm going to do is multiply all of this into this top equation, or into this whole equation here, and we cancel out as we go along. So that should equal now a into x minus 3 plus b multiplied into x minus 2. So what you see there, if I multiply a by x minus 2 times x minus 3, the x minus 2 and that x minus 2 cancel out. Exactly the same here if I multiply x minus 2, x minus 3 into the b, then the x minus 3 then cancels out, leaving me the x minus 2. That's how I've got into that part. So now if I multiply those out, I get ax minus 3a plus bx minus 2b. Now what I'm going to do is gather some terms. We'll keep that as 1 equals. We'll sort of gather some terms together in this first term here. Across these terms, across this whole equation, so really just adding up my b's, adding up my a's, and I gather off a few terms here, so I get ax plus bx plus, I'm just going to put that into brackets there, minus 3a minus 2b. What I've done there is I've brought my x terms into one area and my a and b terms into another, and if I were to extract the x out of that first term there, I get a plus b x plus, I'm going to do the same again there, minus 3a minus 2b. Good. Now for the left hand side of the equation, which we've got here as 1, to equal the right hand side of the equation, the coefficient of x on the left must equal 0. I mean, the coefficient of x is there, but what we haven't done is annotated it. So if the coefficient of x on the left equals 0, then any term with the term x in here, we have x equaling 0. So hence I have 0 equals a plus b, and I'll put an and in there, 1 equals minus 3a minus 2b. And what I've done is equated terms. So I've equated the x terms here. So I said that the x coefficient on the left hand side equals 0, so there's my 0. So all of my x coefficients here are of the 0, and the 1 coefficient on that side equates to my minus 3a minus 2b. Now, as you'll see, and I'll just give myself a little bit more room here. We'll just move that up a bit. Now, as you can see, I have two simultaneous equations, or I have a pair of simultaneous equations. So, just taking, let's change colour again. Why not? It's all fun. Let's have green. So just taking this first equation here, where I've got 0 equals a plus b, therefore dot dot dot, I think that if I were to rearrange that for b, I would say that b equals minus a. So what I'm going to do is substitute anywhere where I've got a b into an equation and substitute that with a minus a. So if we use this equation here, I have 1 equals, I'll write the whole equation first, minus 3a minus 2b. That becomes minus 3a. And anywhere I've got a b, I'm going to put a minus b in there, a minus a in there. So everywhere I've got a b in this equation here, So I now have minus 2 times minus a. And when you gather up that term, so I've got minus 3a minus 2 minus a, the resultant equals minus a. Okay? Therefore, I'm saying that a equals minus 1. There's an answer. And as b equals minus a, do you remember where we got that from? That is that term there and that equation there. That wasn't a very good straight line, but never mind. Then b equals 1. Now, I think I can put that into the first equation. 1 over x minus 2 x minus 3 equals minus 1, that was our a, over x minus 2 plus 1 over, there's my b there, 1 over x minus 3. And in the next video I'll show you how to do that using the substitution method.